So children, this is all about the charges and the methods of charging. Now let us move to the next concept, that is electric lines of forces. Here we go. Electric lines of force. What is meant by electric lines of force? It is an imaginary lines or curve. What are they? They really don't exist. It is a geometrical line to understand the concept clearly. So, what are electric lines of forces means? They are the imaginary lines or imaginary curves along which a unit positive charge would rather move or travel. That means, so you know magnet, a magnet, if you consider a north pole, the north pole of the compass needle always points towards the north direction. Similarly, here also we are imagining, that a unit positive charge would have travelled in one particular direction if it suppose happens to exist. Okay. So, the direction of this unit positive charge are drawn or imagined in the form of lines called as electric lines of force or some electric lines of curves, because it may be in the straight line pattern or it may be curved pattern. So, let us picturize this before going to the properties of this electric lines of forces. First of all, you know, matter consists of two types of charges. One is the positive charge, the other is negatively charged. Positively charged, let us indicate with letter plus. The positive charge, let us represent with the letter plus symbol. Something like this. So, how does the electric lines of force appears means? Those electric lines of force always start from a positive charge and moves away from that. That means the direction of electric lines of force will be something like this. They start from the lines of force always start from the positive charge and move outwards the direction of the positive charge. So, let me also represent the direction of this. Outside, arrow mark indicates outwards. Okay, this indicates the direction of the electric lines of force originating from a positive charge. These electric lines of force always moves away from the positive charge. Okay. Similarly, if you consider a negative charge, the same electric field lines will go inside the negative charge. So, this makes the difference. The electric field lines start from the positive charge and move outward direction, whereas they terminate into the negative charges. Okay? The electric field lines moves inside the negative charge and then stops. So, this is the outward direction from the positive charge, inward direction towards the negative charge. Suppose if you consider two positive charges together, if you keep two positive charges at one place, then let us see how this is a positive charge separately and here is your negative unit positive charge. This is the structure of a unit electric lines of force of a unit positive charge, and here indicates the electric lines of force of a unit negative charge. Suppose if two positive charges are kept together at one place, this is your positive charge, here also your positive charge. As I said that these electric field lines always move outside the positive charge. Few lines I am drawing, children. And this is the direction, outward direction from the positive charge. As we know that this is also positive charge, this is also positive charge. We know that like charges repel each other. So, if you consider the other mode of lines, out of 8 I have drawn only 3 lines. So, let us consider few more lines, children. So, the other lines, they will not go something like this. They will repel. Instead of going that, they will repel back and it takes the shape of something like this. They move outward, okay. Even though they originate here, they move outward. So, this must be the direction. When two like charges, when two positive charges are kept at one place, then all the direction of the electric lines of force are shown as shown in the figure. So, all the electric field lines start moving outwards. Here also they start moving outwards, and those lines which are nearer to this opposite direction, they also start moving in the opposite direction due to the repulsive forces. Similarly, when two negative charges are kept together, something like this, this is a negative charge and here also negative charge, then in that case, let me show you how the electric field lines looks like. Here the electric lines of forces are moving outwards from the positive side. They originate from positive charge and they end up at negative charge. So, they move inwards the negative charge, something like this. Only the direction matters. So, if two negative charges are kept at one place, then it takes of this form. And when two positive charges are kept at one place, it takes this format. So, single positive charge, single negative charge, two like charges, two like positive charges kept at one place, two negative charges kept at one place. Let us also look into that. One more point, children. What if one positive charge and one negative charge are kept at one place? Suppose if one positive charge and one negative charge are kept at one place, then the electric field lines would take some format like this. And the direction of the electric field lines will be, I am drawing more lines, children, to make you understand in a clear, better way. So, very clearly the field lines must go out of the positive charge, out of the positive charge and into the negative charge. So, this is how the shape of the electric field lines looks like when a positive charge was kept nearer to the negatively charged. Okay. The same case, what if a straight conductor is taken? Whenever you imagine a straight conductor, here I am taking a negatively charged straight conductor and one more positive charge I am considering. This be some positive charge. So, then let us look into how the shape would take into the form. So, very clearly the lines will be here. Direction of the lines will be, it will be outwards, and here it will be outward from positive and inwards the negative charge. So, if one straight conductor, negatively charged conductor and a positive charge is taken, the shape of electric line forces must be something like this. Suppose if two straight conductors were taken, the same thing, if the two straight conductors were taken, so one is positively conductor and the other is negative conductor, then the direction of electric field lines will be something like this. So, these are the electric field lines for different structures of a positive charge as well as your negatively charged particles. Okay. So, let us try to understand the properties of these electric field lines. So, children, before that let us recall back what is an electric field lines. These lines actually do not exist. These are the imaginary lines we are thinking about it. Okay. So, we are constructing those imaginary lines to understand the geometrical structure. Okay. So, what are these electric field lines, children? These are they may be a straight lines or they may be a curved lines. So, on which a unit positive charge is supposed to be traveling. That means suppose if you release a positive charge here, the positive charge will move in this direction. If you release a positive charge here, it will move due to repulsion, move in this direction. Suppose if you release a positive charge here, due to attraction it moves here, due to attraction like this. Okay. So, suppose if you release a positive charge here, moves like this. So, this is the imaginary lines or the curves which we are taking it such that the unit positive charge is supposed to be moving. So, let us try to understand the properties of that. So, what we considered is they diverge out from positive charge and converge into negative charge. All the electric field lines, they diverge, come out of the positive charge, and where are they going? They come out of the positive charge and they converge means meet inside the negatively charged, come out of the positive charge and move into the negative charge. So, this is what all the electric field lines diverge out from the positive charge and converge into negative charge. Now, the second one, if you consider any tangent drawn to these electric field lines, then it indicates the direction of the electric field anywhere if you consider. So, it indicates the direction of the electric field lines, like magnetic field, how it exists. Similarly, electric field. So, if you release a magnet and some iron pieces over there, okay, iron particles are being released, then you can imagine because of the magnet it will take some structure. These are called magnetic field lines. Similarly, these are electric field lines. Okay, the tangent drawn to at that particular line. So, this indicates, suppose a tangent is drawn at here, this indicates the direction of electric field line. Suppose if you drop a tangent here, this indicates the direction of electric field line. The tangent drawn to the electric lines of forces indicates the direction of the electric field. These are electric field lines of forces, and that is electric field. Both are different, force and field. Okay. So, now one more thing, no two electric field lines will intersect together. Suppose if they intersect each other, then at that point they must be having two different directions, which is a contradictory statement. So, remember that no two electric field lines will never intersect each other. If they intersect, they must be indicating two different directions. Then Imagine in which direction the positive charge would have moved. So, they will never intersect. So, they diverge from positive charge, converts into negative charge. The tangent drawn to any electric lines or forces indicates the electric field at that point, and no two electric field lines intersect each other. So, now moving to the next one. Electric lines of force are always normal to the conductor. Normal means perpendicular to the conductor. Let us see here. So, normal means this is a positive charge. This will be perpendicular to that. Here it is a positive, it is perpendicular. So, as I told you that we have to consider something like spherical in shape. Electric field lines will be always normal to that conductor, perpendicular to that conductor. Okay. Electric lines of force do not pass through the conductor, they only stop. So, when a conductor is a completely positive charge, they start from originating from the surface of the conductor, not from the inside, only from the surface of the conductor. So, they won't be present inside the conductor, only outside the conductor. Suppose a ball is like considered, if you consider a ball, spherical ball with a complete positive charge, the electric field lines inside this will be 0. They only start originating from the surface of the conductor. Okay. So, the electric field intensity inside the conductor is 0. Electric lines of force are open lines. They are simply open, free lines. That's it. So, number of electric field lines per unit area gives the electric field intensity. How much intensity is there, how much value, how much electricity it consists of is given by using the large number of lines, means more crowded means large electric field it is possessing. Fewer lines are there means its electric field intensity is less. Okay. So, crowded means large value of electric field intensity. Like very less means less number of electric field lines. So, these 2 points indicate the same, children. Electric lines of fields crowded where the field is strong and sparse where the field is weaker. And the number of lines, the number of electric lines of force directly indicates the electric field intensity at that point. Actually, this is, I told you from the beginning that these electric fields are the imaginary lines drawn, or the imaginary curves we have assumed, but there is no physical existence of these electric field lines. We are imagination, we are making the imagination, that's it. Okay, and these electric field lines never form a closed loop. So, closed loop means like circular pattern and all like this, plus is there means like this, like this. So, these electric field lines never form a closed loops. Got it, children? So, that's it, children. And one more thing before concluding, I would like to tell you something. So, flow of charge. What is flow of charge? So, to understand how the charges are flowing and how the charges are moving from one place to another place, just imagine a water. So, water is released from certain height means the water always comes from the highest point. It simply flows from higher region to the lower region. Similarly, if you consider the air always or wind always flows from high pressure region to the low pressure region. Similarly, charges flow from higher potential to the lower potential. So, regarding the potential concept and cell concept, everything, the direction of flow of charge will be discussing in the next letter.